you are aware about the calorimeter. And in the last class we discussed about the functioning of calorimeter. Now by using the calorimeter we will try to do an estimation. There is estimation of reducing sugar, that is a glucose, by using the DNS method. Here the principle is concerned, glucose is a good reducing agent. That's what it is called as reducing sugar. So here what happens here, the reagent, DNS reagent is reduced into, DNS is nothing but 3,5-dinitrosilicic acid. In the presence of a good reducing agent, glucose is a good reducing agent, so reduction takes place. So what happens here, 3-amino-5-nitrosilicic acid is produced over here, and this 3,5-nitrosilicic acid is yellow in color, and once it is reduced to amino-nitrosilicic acid, it will be converted into orange color, reddish orange color. So this orange colored solution, its intensity can be measured by using the calorimeter here. It absorbs the wavelength at 540 nanometers. So at 540 nanometers here, the quantity of the glucose, glucose is a colorless solution. If you dissolve the glucose into water, it will be colorless. So you cannot directly measure the glucose concentrations. So it has to be converted into colorful substance. See here what happened, this 3,5-nitrosilicic acid, basically it is yellow in color, and the quantity of the glucose, suppose 1 mole of glucose is there, it will be converting 1 mole of 3,5-nitrosilicic acid into 3-amino-5-nitrosilicic acid. So the equal amount of glucose is responsible for conversion of yellow substance into orange substance. More the concentration of glucose present over there, it will be converting more the orange color substance over there. So it is called as directly proportional. Whatever the concentration, 1 molar if it is there, it will be converting 1 molar amino-nitrosilicic acid over there. So we'll be for this one we will be using dinitrosilicic acid. Dinitrosilicic acid, the composition I have given, in which you have DNS reagent. 1 gram of DNS reagent is dissolved in 20 ml of ethanol. Actually, it is partially soluble in water, so you are supposed to dissolve it in ethanol. And then sodium potassium tartrate, Michelli salt it is called as. Sodium potassium tartrate, 30 grams of sodium potassium tartrate you are supposed to dissolve in 50 ml of water. Then you are supposed to prepare 2 molar NaOH solution. To make a final preparation, you are supposed to dissolve 20 ml of DNS reagent plus 50 ml of sodium potassium tartrate plus 20 ml of NaOH, 2 molar NaOH. And normally excess amount of this DNS crystals will be there in that one. You are supposed to filter it, and after filtration you are supposed to adjust the volume. You are supposed to make up the volume to 100 ml. So this is your DNS reagent. Okay, now we'll prepare the DNA. Standard DNA will prepare with a concentration of 1 mg per ml. 1 mg per ml DNA, this glucose solution that you are supposed to prepare. You know, glucose is easily gets dissolved in water, so you are supposed to take double distilled water. You are supposed to take distilled water or double distilled water you can take, and in this one 100 ml water you can take, and 100 mg of glucose you can weigh and you can dissolve in it. So the solution is 1 mg per ml. Okay, if you can weigh 50 mg, then you can take 50 ml of water and 50 mg of whatever your glucose is there, that should be kept into that one. Okay, so accuracy may not be there if you are going with 50 mg, so better you go with the 100 mg. Weigh 100 mg of glucose and dissolve it in 100. The best strategy is dissolve it in 90 ml. Once it is completely dissolved, by using the standard flask, adjust the volume to 100 ml. See here 100 mg is a small weight, but it is a normal recommended procedure. Always you should dissolve it in lower volume, then adjust it to the final value whatever it is required. So you are 100 mg you are dissolving. Suppose you are dissolving in 1 gram. So the final value gets changed. So the concentration will not be the same. So it is always advised to take 80 or 90 ml, then dissolve your whatever the sugar is there, then finally you make it to the final value. Okay. So this is a standard glucose that we have prepared. Now for the estimation is concerned, you are supposed to prepare the aliquots. These are called as aliquots. First, we will be taking 12 test tubes. 12 test tubes you are supposed to take. In the first test tube, you are supposed to should not add any standard glucose. It serves as a blank. It serves as a blank, and you are supposed to add 1 ml of water to it. And then the concentration over here is 0. Glucose concentration is 0 here. So it serves as a blank. Then add 3 ml of DNS reagent to it, and put aluminium foil and keep it ready for the boiling. And rest of the things, see, you are supposed to take 0.1 ml of standard glucose. See, 1 ml is having 1 mg per ml. 1 mg is nothing but 1000 milligrams. So 0.1 mg will become how much? It is 100 micrograms. It is having 100 micrograms in it. 1 mg is 1000 micrograms. So 0.1 mg is 100 micrograms. Like this, you are supposed to prepare different aliquots. 0.2 ml of standard glucose that you are supposed to take. 0.8 ml of water you are supposed to add. See, these two put together should come 1 ml. Glucose plus water, these two should come 1 ml. So 0.2 ml of standard DNA, standard protein, standard glucose makes 200 micrograms. 0.3 ml of glucose makes 300 micrograms. 0.4 ml of standard glucose makes 400 micrograms. 0.5 500, 0.6 600, 0.7 700, 0.8 800, 0.9 900, and 1 ml of standard glucose without water makes 1000 micrograms. That is as it is we are taking. As it is we are taking over there. Yes. And in all these tubes you are supposed to add 3 ml of reagent, DNS reagent you are supposed to add. Everywhere 3 ml of standard reagent should be added. Then you are supposed to take unknown. See, by using this standard concentration, you will be getting some values. You will be boiling in a boiling water bath for 10 minutes. You will be boiling it, boiling water bath for 10 minutes. And see, after putting that DNS reagent, cover it with the aluminium foil. Or like a cotton plug also can be preferred. But see, vapor should not go outside. If the vapor is going out, what happened? The dilutions will be altered. Actually, standard dilutions we have prepared. Isn't it? If more water is going over there, it will be concentrated suspension. So you should make sure that no vapor is going out. Then keep it for the boiling for 10 minutes. Then allow it for 1 to 2 minutes for the cooling. Then start taking the readings at 549. First, initially you are supposed to keep the blank over there. Yes. Then make it 0. Yes. Then subsequently you take the readings for the remaining samples. Like all 10 concentration that you have worked, you are supposed to take. Now you are supposed to construct a standard graph.
Okay.
Standard graph you are supposed to construct. Here OD versus concentration. You know the concentration, no?
Yes.
It is 0, 100, 200, 300, 400, 500, 600, 700, 800, 900, 1000. These are the known concentrations. Isn't it?
Yes.
Known concentrations are there, and you will be getting OD. Yes. Optical density you will be measuring in the colorimeter. Yes. So here concentrations are there, 100, 200, 300, 400, something concentrations you will be getting, and here there will be a OD. And if you plot the graph, it will be something like this. You will be getting a graph, and whichever the unknown that you want to measure. See, these solutions concentrations are known for you.
Yes.
So this is called a standard graph preparation. Now you are supposed to take some unknown. You want to find out some glucose in a food sample. Some food sample is given, like glucon D is being consumed, and many orange rings, many things are there. So you want to measure how much glucose actually is there in that one. You take it and do the dilutions. And finally you can take unknown sample 0.5 ml. 0.5 ml of water can be added to that one. If the concentration is too less, then directly 1 ml you can take unknown directly and no water should be added to it. Then as usual 3 ml of DNA should be added to it, boil it 10 minutes along with the standard itself and take the OD for the unknown also. Now you will be getting some OD, isn't it?
Yes.
Now plot it over see there is a graph, standard graph, suppose it is coming somewhere here. So see where it coincides with the concentration. That is the concentration of glucose present in the given sample. This is the application of calorimeter that's measuring the unknown concentrations. We need to find out the protein concentration, we need to find out the DNA concentration, RNA concentration, glucose concentrations, many metabolites concentrations also we need to do, antibiotics concentrations that we are supposed to do. So the elements which don't have direct color, they can be, let's see, this is a indirect reaction actually. This is an indirect reaction. Sometimes what happens, see the peptide bond is there in proteins, the peptide bond directly binds with the copper to give a color over there, blue color complexes are formed. That is a direct reaction, but this is the indirect reaction. Your molecule, glucose molecule reduces 3,5-nitrosalicylic acid into 3-amino-5-nitrosalicylic acid. So reduction reaction is going on. Reduction reaction is indirect reaction. Okay, if the molecule directly it is undergoing the color change, that is called as direct reactions. So whatever may be, either the direct or indirect reactions, ultimately we are getting some color, and that color is directly proportional to the concentration of the substance that we are measuring over there. So what is the Beer-Lambert's law? Which this is the principle of working this calorimeter.
The concentration and the rate of intensity is directly proportional to the thickness.
If you are using single beam light, same wavelength, and the path of the light passage is made constant, L is constant, then the absorption of light is directly proportional to the concentration of the substance under test. Okay, two things here, two should be constant over there. One, the wavelength of the light, monochromatic beam that we are supposed to use here. Single wavelength it will be having. So if you are using monochromatic light of constant wavelength, in the sense that is constant value. No, we are not altering every time. So fixed wavelength I am taking. Second one, I am taking the fixed length of the cuvette. That's the the time that it passes through the cuvette, isn't it? That is fixed over there. This is a cuvette, no?
Yes.
So this length of the cuvette should be constant. It should not be altered. Second one, the wavelength of the light should be constant. In these two conditions, the light absorbed by the substance is directly proportional to the concentration of the substance. This is what Beer-Lambert's law states. So here, as the concentration increases, see now here 100, 200, 300, 400. As the concentration increases, its absorption or optical density also increases. So that's what see it is showing the linear increase. So till what concentration that increase will be taking place?
Till optical density and concentration co-aligns.
Is it lifelong, like whatever the time? No, it will not do. So normally for the calorimeter we considered 0.8 is the best value. 0.8 is considered that. So if the OD you are getting is more than 0.8,
Okay.
what shall I do? If the OD is 0.8, if I am getting up to 0.8, accuracy will be there. So a linear increase is there up to 0.8. If it is a more than 0.8, you are supposed to do the dilution of your sample, not the final the color form.
Okay.
The glucose concentration itself you are supposed to do the dilutions. So do 10-fold dilution or 5-fold dilutions and do it again. What? Reduction reaction. You do again, suppose you did a glucose estimation and unknown concentration you are getting some 2.4. So it is beyond the limit of Beer-Lambert's law.
Yes.
It is beyond the limit of Beer-Lambert's law. So what you are supposed to do the
Dilution.
dilution of that one. See, one time you do 10-fold dilution you do, still you are getting 1.2. Then again another time you are supposed to 10-fold or 5-fold dilution you do. Then you do the second time you take the OD. So if it is coming in the range of 0.5, 0.8, so you take that concentration, concentration you will get. Now you multiply with the dilution factors. You multiply it with the see, one time we did 10-fold dilution, another time we did with the 5-time dilution. So you multiply. Suppose you are getting 200 microgram concentration, 200 into 10 into 5. Whatever the concentration that comes, that is your final concentration. Okay. Now what we are supposed to do? Standard. Somebody can do standard glucose preparation and DNS reagent that you are supposed to prepare. 3 ml each is required. So total 12 tubes are there here. 12 into 3. 36, 50 ml of DNS reagent better you prepare. And glucose is not that expensive, so 100 ml you can prepare, that's not a problem. And this tubes, cuvettes, other things you are supposed to take care.
Yes.
Okay, now you can start the experiment.